So here is section 2.5, exercise 5. And in exercise 5, we are asked to find the derivative dy dx, where we know that x cubed minus x plus y squared is equal to 7. Now, in some ways, this isn't a real interesting example because I could solve for y and do it that way, but nonetheless, hey, we can do this. So remember that, and I'll do this to remind us that this is what we're doing each time. We're taking the derivative of the left side, we're taking the derivative of the right side, and we're saying those resulting functions of x are equal to each other. So we started with two functions that are equal to each other, and then we have these two others, new ones, that are made by the derivative. They're equal to each other, well, because the derivative of a function is unique. And so here we have our 3x squared minus 1 plus, and I look at that and I just, well, it's just y squared, so that's just 2y, but then I have to remember to use the chain rule and say, well, y is a function of x, so I have to multiply by its derivative as well. I'm just not sure what that is. And then equals 0. So now, get everything involving dy dx on the left side, everything else on the right side. So I have 2y dy dx is equal to 1 minus 3x squared. Okay, now solve for dy dx, and I have my dy dx is equal to 1 minus 3x squared over 2y. And there we go. There is exercise 5.